Okay, for this week's lecture, we're going to be looking at a very short chapter in the book, but I've got some other information to go along with it. It starts on page 659, chapter 19, about construction drawings and how they're organized. In addition to the drawing section, I'm also going to be including some information on specifications. There are two components to any type of construction document set, and that is the drawing portion and the specifications portion. We not only give graphic representations of what we want to put in there, but we also include specifications, written descriptions of the material that we're putting into our building construction. Everything from concrete mixtures and uh, uh, specific recipes for our concrete, our rebar, our doors, our windows, our grading, how big the soils composition is going to be. Those types of things are all including in the specs. So we'll take a look at those. We're going to start off with drawings. If you look at that page 19 and kind of thumb ahead to page 663, they show a series of drawings, and there's a specific order that drawings need to go in. Normally we start out with a cover sheet that describes the drawing of the project. There may be an architectural rendering on it. Sometimes they'll put their index. And then we have general information, which may be symbol libraries, basically a dictionary of the symbols and abbreviations that they might use in the drawings. We may have a quantity takeoff. We have our civil engineering drawings then, which are surveys and maps, soil information, erosion control, landscaping. Each of these drawings all the way down through the list you can see in this PDF file here. We start out with architectural, civil. These are the designations for the sheet type, how you would number it. So an architectural sheet would be an A designation, civil would be C, all the way down to structural in S. Resource might be recovery type materials, recyclables, telecommunications. All different types of disciplines would have their own drawing number style. So if we look on page 2 in this PDF file, let me see if I can view it as a full screen there, so it's shows up a little better. We can see some general descriptions on the numbering here, and this is one type. The American Institute for Architects actually has a specific numbering. This is just a good example. Anywhere sheets 01 through 0.99 are your indexes, legends, notes, abbreviations, and maps. Anything 01 or 1.01 to 1.99 sheet numbering would be plans for plumbing. So it might be a P1.01, which would be maybe a plumbing plan. If it's an A1.01, would be an architectural plan. 2.01 to 2.99 are elevations, exterior elevations. Our 3 series are sections. In other words, we're going to cut through our object or our construction through the middle to see what's inside. Large scale plans would be in the 4 series. Details are 5s. Schedules and diagrams are in the 6s. And then we have some user defines and then some 3D perspectives that end up in the 9s. Down here we have some sample locations. So an S3.03 would be a structural section set. So it's S for structural. We look up here at 3 to 3.99 is sections. So we know if we're thumbing through the bottom right-hand corner of our sheet files and we see the S series, we know we're in our structural drawings. And we know if it says 3, it's a section. If it's a 5, it's going to be detailed drawings of those structural details. And it's sheet number 10. So it's S5, which is structural details, sheet 10. And, you know, there's a general consensus that this stuff will always be the same, but different companies, of course, adopt different standards, and sometimes they're hard to change. Here we see kind of the organization. We start with our cover sheets. We've got our site information, our exterior elevations, our floor plans with electrical, structural, and plumbing, foundation plans, structural and plumbing, roof plans, sections, and details. Now, a lot of times they'll put all of the floor plans in one area and then go to the electrical or the structural and put those in separate sections with the S's or the P's and whatnot. Oops, let me get out of this one. So that's a basic. I'm going to upload these into the Blackboard site just so you can review them if you want. Let me close this one out. Before we get into this, let's just take a look at, here's the National CAD Standard version 5 for drawing set organizations. And this gets into a little bit more detail, and this is the official. So we have the designator, the discipline designator here, and we'll see some examples. Here we have general hazardous materials. So anytime you see a page that starts with an H, it's going to reference hazardous material. Our architectural, structural, so the alphabet is here. Anytime you're doing a mechanical drawing, it's going to be an M drawing. If we look further down, you can see where some of these, they're going ET for electrical telecommunications. If they go to a level 2 where they might be combining these things together. TT for telecommunications. So here we have TA would be audio visual, TC clock and program. So you can have multiple designators. These are our sheet type designators, similar to what we just saw in the previous one with this N designator, which would be 0 for general, 1 for plans, 2 for elevations, 3 for sections, 4 for large scale. And then the last 2 are sheet sequence numbers. So the first 2 are the discipline. The second one is what type of drawing it is. And the last 2 would be the sheet number sequence. So if you have multiple drawings for structural elevations, you'd have 01, 02, 03 down here up to 99. So some of these can get quite complex, but they basically follow the same format. Here we have an architectural drawing 102, and it has been revised. R1 indicates that the drawing has been revised, a partially revised floor plan. If it has X1, it's going to indicate that it is a totally revised floor plan. And then you may have A1, which may indicate phase 1 of a sequenced construction floor plan. So they may have multiple drawings indicating a phased or sequenced operation going on with these drawings. So once you get a set of drawings, you're going to kind of look at them and determine exactly how these things are put together. So this is a good reference on how we number sheets. Some of the stuff we do won't get this involved. It'll certainly include some of this information, but until you get into 100 and 200 sheet plan sets, you probably won't bother too much with this, other than the fact that if it's a mechanical drawing, we'll label it as an M. If it's a civil drawing, it'll be a C. If it's an architectural drawing, it'll be an A-type drawing. But good information to know in how these are put together. So if you're able to look through a set of plans, which we'll do next, you can kind of identify those. So I'm going to close this one out. Now this is a building that you'll be familiar with. This is the recreation center here at the university, and we've selected, actually Will, a previous teacher, had selected some of our drawings from this set. This isn't a complete set from the Student Recreation and Fitness Center, but you can see we've got a C102, which is our drainage and grading plan. And then we have a series of architectural drawings, including, there's our exterior elevations, our building sections, see how they're set in a 3 designation, our second floor plans overall. We've got some structural drawings down here, and we've got some structural framing. So this is 21 sheets. Let's take a look at it. And here's our first sheet, C102, which is our civil drawing. And it's kind of, let me give us a full screen here. See if I can, oh shoot. Go back the other way. always do that. I'm going to have to use my zooming tools here. So let's go in and take a look at some of the information on this drawing so we can read it. Right down here we have what's at the south end of the rec center. This is just outside the swimming pool area. The site doesn't show that just yet, but we have a bioretention pond. So we can see our contours here for our grading. So if you walk by the site, you'll notice there's a depression here, and that is designed to hold rainwater coming off the roof in the event of a heavy rainstorm, rather than washing out the culverts and whatnot. It's designed to hold excess water and allow it to drain out at a regular rate. And you can see these utility lines. This is a storm drain coming down here that has an outflow device that has an invert of 128-foot elevation. You can see it's right on this contour line at 128. The bottom of that bioretention pond is at 124. So there's a 4-foot depression from here to where this outfall comes out. All of these outfalls come out at roughly 128. Now what happens is, as soon as that water starts building up 6 feet or more, we have an outflow. So, or excuse me, 6 inches or more. So once this starts building up beyond this 128, in other words, you're going to have 4 feet of water in here. When it gets up 6 inches above that, it's going to start flowing out through this rock basin and follow this swale down until it gets into this is a level lip spreader. This allows the water to flow out evenly so it doesn't all end up in one spot. And if you follow it down even further, we'll get down into some areas where this will outflow underneath the bike trail through a culvert into a wet area. But generally it doesn't happen too often. So that's one area. Let's take a look over here on the front side. So this is where you enter the rec center, right in this location. These are our paving stones. It gives us elevations at this level. We have a storm drain that runs underneath this area. This is a catch basin, CB7. It's located just at the corner of that entrance. It has a rim elevation of 134.8. This is catch basin 7. Has an 18-inch invert at 131. In other words, the diameter of the pipe coming in is at 131 feet. The 18-inch out invert, so it comes in higher than, and it has a basin there, so it holds the water. And there's an 18-inch invert out, which comes down in this direction at 130.64 feet. So it's actually a little bit lower than the input, but it allows that water to fill up into that location first. So that's some of our outside. These are all, SD is a storm drain, so you can see all these catch basins. There's one right up here just outside the sidewalk underneath those stones that has an outflow going down into the catch basin. If we look up here in the upper corners, we can see some more outlying materials, mostly your inverts and your outflow. So this is the upper side. You can see how this slopes up. It's 142-foot elevation. It comes down, slides across this area, and gives us our grade going up. You'll notice that these dotted lines were the old grades, and these are the new grades here where they've built that area up. Let's go back out. We'll take a look on this side. We can see some more inverts. Let's go between these two pipes right here. So what we can see is we've got a catch basin up here, catch basin 3, which has a rim elevation of 141.4. And down here we have another catch basin 4, which has a rim elevation of 137.8. These are survey points of elevation taken from our geographical maps and whatnot and our regular surveys. So this one has an 18-inch out at 132.6. and it goes into this catch basin at 131.68. So if you subtract 131.68 from 132.6, it would tell us that how much of a slope that pipe has, and in this case it actually gives us that that slope is dropping at 0.009 feet per foot. It has a length of 102 feet, and it's an 18-inch storm drain. So good information. If we ever have to get underground, we know what we're looking at here. A lot of information. Some of this information that's in the clouds, that's clouded here, is information that they've identified, either made changes or sent it through as some form of identification, or could just be shrubbery. But you'll notice a lot of this stuff has clouds around it. This has a note 1. So what is note 1 in the triangle? Let's see if it's located on here somewhere. It may be on a different page, but we'll see. I don't see it there. There might have been an attachment to that piece. So let's look at our next page, which gets into our architectural drawings. We can see our scale. Before I go there, there's our scale down here. So we have a physical scale on the drawing, and it would actually tell us in this title block. Let me zoom into this area. I want to just drag it. There we go. So here we can see it's a 1 inch equals 30 feet in the scale. The grading and drainage plan is what it is. It gives us some information on this key plan that says, oh, there it is right there. There's that triangle with the 1, which was addendum 5. An addendum is a change in the construction documents that happened after the construction started. So we can see some history down here. On 3/11/2005, they developed the schematic design package. 3 months later, they had the design development going. On July 22nd, 2005, we had our stormwater permitting, which means that we were permitted to go ahead and move forward. Apparently, there was a 50% progress submission. 8/31, there was another stormwater permit that went through. We had an 85% progress set done in September. We had our 100% construction documents done in October. We had progress was issued 12/22. We did final VE bid documents. Now VE stands for value engineering, meaning that if originally the job came in over budget, they had to maybe make some changes to bring it to within budget. So our final bid documents came in on January 5th, 2006, and we were ready to get moving. So now let's move to our next page and take a look at some of the information here. A002 is architectural information. So we have, first of all, information on some hatching symbols. If we see this on a drawing, it's fibrous insulation. If we see this, it's fiberboard, acoustical tile ceiling, ceramic, quarry tile, concrete, precast and insight, lightweight concrete, gravel or porous material. If we see these symbols used as hatching, we know what the material is by just looking at it. So we can see all of our different hatching symbols. In plan view, we'll see gypsum board ceiling, acoustical tile, metal panel ceiling, some plastic glazing, recessed, different types of light fixtures, utilities. If we look over here, we've got firewall petition information or smoke petitions. Match lines indicate that in order to see the drawing on a building of this size, they had to put it in 2 different pieces of paper. So you have a match line so you can put those things together if you want to see what the overall building looks like. Even things like CG2 and CG1, these are corner guards which are there to protect the wall petitions from carts being banged around and that type of thing. And this symbol here would indicate a petition type, which is on the petition schedule. So if you see a line going through the wall with a diamond shape and a number, and you go look at your petition schedule, it would tell you what type of wall construction that is in the drawing itself. If we move down, oh shoot. We have some information here on abbreviations. And if you see something in the drawings that you don't understand what the abbreviation means, for instance, DT for drain tile, you'll only see these designations in one type, so they're listed on the cover sheet, so they won't be confused. No matter what drawing you're looking at, if it says BET, it just means between. So all of the initials on our drawings can be referred back to this second page within the cover sheet, so we can determine EWC is a good one. I always wonder when I look at the drawings, EWC, it's an electric water cooler, so a drinking fountain would be listed as an EWC. Let's see, FE should be fire extinguisher. Let's see if we can find, there's our Fs. Yeah, it's probably up here. Get up to the top. We also have drinking fountain, DF. So a lot of times the architects will use these. Yeah. Maybe I went by fire extinguisher F. Yeah. Usually it's FE for a fire extinguisher, but I don't see it here. I might be missing it, but we'll see. If we find one on our floor plans, we'll see what it looks like. So let's go to our next page. And this is where we're going to start getting into our floor plans. Here you can see the rec center. There's your swimming pool. Here's our locker rooms. These are the basketball courts, the floor hockey area, the weightlifting, the offices downstairs, your entrance area. So we can go down and look at some of this information. Let's start down here by the entrance. So down here we can see a wall type W, whatever this is. And inside here, you'll notice we have this symbol. These are elevations symbols. So on sheet A604, elevation 8 is going to be a view standing in the middle of the room looking at this wall right here from the inside. So if I want to know what that wall looks like from the inside, I'm going to go to A604. Now, do we have an A604 here? Let's see if they included A604. A602, just of the gym. So let's go back and take a look and see if we have a set. There it is right there. We're going to look at this. A602, elevation 2, 3 is going to be looking at this wall. A603 is going to be looking at this wall. So if I want to see what the gymnasium is going to look like, I'm going to look for A602, elevation 2-3. So now we'll go out. We'll go look for A602. Hopefully I got them here. Oops, there it is. Just went by it. A602. So we're standing in the gymnasium, and I want to look at, see, you've done it in two segments because it's so big. So they have a match line here. You can see it's columns 1, 2, 3, 4, 5, 6, 7. And it picks up 7 down here, 7, 8, 9, 10, 11, 12. So if I were to cut these out and put them end to end, I'd be able to look in here. I know that this is the west side because it has the dasher boards here for the floor hockey. There's our running track. So if I want to take a look and see what this area looks like, crap. Right here, there's our basketball hoops that swing down, emergency exit up on the top, tells me what's in the ceiling. There's some ductwork that runs across here. It goes down to the below the track in the back wall. It's going to be exit out at 13 feet of AFF, which is above finished floor. Tells me the wall paneling here is fiber reinforced cement panels, stainless steel columns, and here we have a section through the wall, section 3 A602, so, and section 2 A602. So if we look at that, that is actually a section through here, so we can see down in this area a section through the building, interior elevation that's looking towards the field, the floor hockey area. There's your basketball hoops hanging down. There's our enclosure, window enclosures at the end. Shows us some duck sock or duck material up at the top, some hanging lights. And down here we've got a detail. It's on A601. Of course, I just messed it up again. So if you wonder what this is, I wonder we have sheet A801 has a large detail of this connection. Of course, we probably don't have A801, but let's take a look. No, A602 is the only thing he put in there, so we don't have A801. I'd have to pull it up. But we do have the S's, 302s, and 101s, so we'll take a look at those. Here's the second floor of the gym with the running track, the elevation down below. You can see that they probably duplicated these, which they did. There's your elevation 2 on A602. A6021 is looking in this direction. If we look down here at our stairwells, we can see our telephone data closet. There's an electrical closet. We got some wooden cubbies up here where you can put your clothes. Rubber base, mechanical shaft comes up through. EWC is a electric water cooler. There's two of them here. We see an elevation 7, which is on sheet A606. We don't have a copy of that, so I can't really take a look at it. Here we have an elevation 1 on A607, which would look at this stairway. These are sections through the track. Sheet 11, detail 11, A825. This would show up here. Gives us finished floor elevations. This one's at 152 feet. If we want to find out what the difference in height is, just using our plans between 152 and the first floor, get down here, we can see we have a 136 finished floor, so it would be the difference between 152 and 136 would give us our information on floor elevation differences, so we could determine what our height is, finished floor to finished floor. All of these little circles indicate details of the construction on different sheets. A427 is detail 2. So if I wanted to know what this looked like up close, do I have an A427? Let's take a look. Probably not. 401, 425. Oh, A427. So this is just a partial, and I don't know exactly, but if it was this one up here, for instance, we could take a look at that and see in plan view all of the material that's included in that detail. Let's use this one here. This is just an end wall. East atrium curtain wall panel detail. So it shows us where the 6-inch metal stud framing, painted gypsum wallboard, 6-inch metal stud framing, spray foam insulation, air vapor barrier with a lap, WTH, not sure what that, barrier lap with spray foam insulation, more spray foam insulation, the exterior sheathing, so this is actually the exterior of the building, your metal studs, and then on the inside we've got If we look at this arrow, it's 5/8 painted gypsum wallboard, 3 5/8 metal stud framing, and more gypsum wallboard on the inside. So within each plan view, we have these details that allow us to blow it up and see some really intricate details on how these things are laid out. If I needed to cut a hole through this wall, I could open it up, I could look at these plans and details and determine pretty much where things should be laid out, provided that the contractor built it the way the drawings show. So let's and another detail here, you can see the stone on the outside of the building, the insulation. These are actually masonry ties here. This indicates provide wall ties typical. This is what holds the masonry in place against the interior structural framing. So there is an airspace between the masonry and the insulation to allow moisture to escape and whatnot. Some floor grates, there's a radiator atrium cover here, window glass, spray foam insulation all the way through, and then end covers. This is fire insulation around the outside of this steel column. I'm not sure if there's an arrow pointing to that, but you can see it's on column line H1. Again, just a lot of information. If I wanted to know what the overall thickness, I could just total these things up and figure that out. We looked at A602. Now we've got some structural drawings. S101 just gives us our structural column locations all the way around the building. You can see the open area where the gymnasiums are, and then the column locations where it's supporting the rest of the area. Down here is our swimming pool. So each of these columns is designated by a number or a letter going this way. So column line D6 would be right here. No column there, but when you get down here, you've got a column line D10 or whatever that number is there. So if you wanted to identify that column, you could do it. It's just some blow-ups of the locations. So there's a column line G, which is this run through. These dotted lines here indicate control joints. Whenever we pour large areas of concrete, we need to make sure that we can control where the concrete will shrink and crack. So by putting control joints in this area at those column locations, we can force it to crack at that location, and then it's filled with a elastomeric material so that you don't see wide cracks running across the floor. Here's an addendum 1 copy. It says there's a step footing right here, but just a blow up of how that works. Now, what we're looking at here is actually the structural drawing, S101. Now we can actually see the steel that's in the building. If I look a little closer here, we can see that on this column we've got these W24 by 68 steel beams running across, and in between those are these W14 by 22 steel beams. The indication W indicates it's a wide flange steel. The 14 indicates the height of that steel in inches, and the 22 indicates the pounds per linear foot of that steel going down. So it's a 14-inch high beam. It's 22 pounds per linear foot, which sounds light. You can see this one is 24 inches tall and it's 68 pounds per linear foot. Or maybe it's linear inch. Sounds more reasonable. Per inch. I'll have to take a look at that. But it is height of beam and then weight per distance. So I think it's probably in inches. So you can see all the different size beams where they connect. Normally with structural drawings like this, you only see the one line drawings indicating with the size of the beam, and any of the connection points would be indicated on larger detail sheets. Here's some elevation cross bracing, same type of steel. If I look at this one, we can see it's got some, you'll notice in the gymnasium area, these diagonal 1.5-inch diameter rods that are there for diagonal bracing on these glulam beams in the gymnasium. And that's what those are there for, is to keep those things from twisting. Some more structural diagonal bracing. Here we have some foundation details. S502, foundation is part of the structure, so if I want to just take a look at one of these, first of all, it shows us top of footing elevations, top of wall, top of slab, and these are all listed on our plan, so that's why it says it. You can see our hatching indicates compacted structural fill on the outside, rigid installation, earthwork on the inside, support drainage is this crushed stone. Then we have reinforced concrete. Underneath the concrete, there is a certain dimension of insulation. And then we have our curtain wall listed up here on top of the foundation. So every area has a cross section that we can identify. We can also see our reinforcing steel in the concrete here. This is a number 5 at 18 inches on center each face. Number 5 rebar. These are 5/8. So the number of the rebar represents how many eighths of an inch in diameter it is. So a number 5 rebar would be 5/8 of an inch. A number 4 rebar would be 1/2 inch. So that's part of that information. See if there's anything else here we can look at. Just a blow up of the detail. Then we've got some more structural drawing here. Some pre-made slabs. Here's some details. This is probably similar to what we were looking at previously. Let me see if I can rotate that page clockwise. And we'll just take a look at, and you can actually see these exposed out in the gymnasium where these turnbuckles come in to the steel plates on the columns for diagonal bracing. These 2.5-inch diameter rods, typical. They're pretty good sized pieces, so you can't really miss them. And what we have out here are some welding symbols. So this is a typical 1/4-inch fillet weld, meaning it's just a 45-degree angle weld. This indicates it's going to be all around. So this plate is welded all the way around with a 1/4-inch fillet weld. This is just welded on this side here and here, typical. And this is a tube steel. It's an HSS, which I believe is tube steel 12 inches by 6 inches. We have a 1/2-inch steel gusset plate, which is a vertical piece, and that's also welded 1/4-inch fillet all the way around. And that has these bolts going through that hook on to the turnbuckles and the rods. And it just shows a typical bolted and welded connection on how these things are put together. So it's kind of interesting, especially doing kind of some forensic look. If I have a project I need to do in this building 10 years later, I can pull up these plans and see how it was put together originally on things that are no longer visible from the outside. So that's it for the rec center plans. I won't put those up online. I just wanted to kind of run through those and show you the organization, but this is probably 100 sheets of paper in its full set. What we looked at here was just some minor pieces. So I'm going to close that out. No, I don't want to close it, save it. And I want to take a look at other things that we look at in construction documents would be local ordinances. This happens to be the town of Orono's local ordinances, and they cover everything from antenna heights, agriculture. This is their definition, so I'm going to put this up there. Billboards, canopies, everything has a designation. A two-family dwelling is a detached shall mean a freestanding residential dwelling unit designed for and occupied by one family only. That's a single family dwelling. A two-family dwelling shall mean a detached residential building containing 2 dwelling units other than single family attached units designed for occupancy by more than 2 families. Anytime there's been questions regarding whether I can turn my home into a 2-family home, You know, there's been definition requirements, so that's how a lot of this stuff comes about. And this is just the town of Orono, with definitions of everything you can imagine. It's basically a dictionary of everything that shows um, in the town of Orono's ordinances. A flag lot, for instance, shall mean a lot, parcel of land that is located to the rear of another lot or lots which front on an improved public street and is not able to be developed solely because it lacks the necessary minimum footage on said improved public street. A flag lot shall consist of an access strip and a rear lot as shown in Figure A. So this is your access strip, 25-foot minimum width, to a flag lot, meaning it's landlocked, it has access to the public street, but it's not wide enough to put a public street access in there because of setbacks. 100-year floods, flood elevation, floodplains. I won't go through this whole thing, but just something to kind of be aware of. If you're ever in a situation in an engineering firm where you're designing something, you need to work with the local authorities having jurisdiction, which includes the building inspector, the town council, the fire marshal, the local fire captain, whoever takes care of these ordinances and enforces them needs to be aware of what you're doing. So if they start talking to you about flag lots, rather than kind of scratching your head, having somewhat of a knowledge of these types of items is helpful. So kind of skimming through this and, you know, keeping this on hand too. If you need to refer to it based on an email or a conversation, you can always look through and find this information online. Now lastly, I want to mention specifications. Again, we have our CAD drawings put together, but we also have specifications, and specifications follow a specific format. Specs, and let's click on it right here. I can go to RCAT, which is a place where specifications are available. And what we're using here is a 3-part CSI specification. CSI stands for Construction Specification Institute. They are the ones that maintain and design this information. We're working in the 2014 master format. If I switch to, I don't know whether I can switch here, but to 95, it has a little different numbering configuration. What we use is the 2014. 2014 CSI configuration is your 0 or your 1s and your 2s are your general conditions. When we actually get into material, we start in section 3, which is concrete. We go all the way down to section 41, which is material processing and handling. We got transportation, earthwork, and site work. Used to be at the beginning, now they're at the end. Electrical, communications, furnishings, equipment, openings, wood and plastic. If I just wanted to find a specification for, let's keep it simple. Let's say door hinges. Here we have a number of manufacturers that have specifications for hinges. I know that Hagar is a hinge manufacturer. We probably have, I know Stanley makes hinges. They're probably listed in here somewhere. Or they may be under a different name. But let's just look at Hagar companies. And there's full surface hinges for doors. We got concealed leaf hinges. And I want to see the specifications for this particular full surface hinge. And I just want to, at this point, I can download it as a Word document. I can look at it as an RTF or WordPerfect or just a plain text, but in this case, let's just view it. Now the things you see in red here are notes to specifier. They don't necessarily need to print out, but it's broken down into 3 sections. Part 1 is general. Part 2 is products. Part 3 is execution, I believe. We can get down to it. Come on. This obviously calls for everything. There it is. Part 3, execution. So starting back up at the top, general. What they want you to do is go in and basically edit this document, take out the stuff that's not particular to your drawing, or your project. In this case, we may only want butts and hinges. Hinges are another name for hinges or butts. They have some testing information for different types of door hardware. It's in Division 8, which is part of openings, meaning doors and windows. Building codes, IBC, International Building Code, California. So if I'm not concerned about the California State Fire Marshal or the City of New York, these are things that I would delete. And it says here, note to specifier, delete building code not required. Again, they put in everything. It's easier to go in and delete the stuff you don't need than it is to sit there and retype it or cut and paste it where you want to. So these specifications get rather hefty for just hinges on doors. And you have to do this for lock sets, door stops, door windows. Everything has its own spec section. And it protects you. For instance, delivery, storage, and handling. We're not just going to have this stuff dumped on the site and put in a corner and then forgotten about, and it can't be found later. Somebody's taken it to a metal recycler. So we need to provide a clean, dry, secure room for hardware delivered to the project, but not yet installed. Furnish hardware with each unit marked and numbered in accordance with the approved finished hardware schedule. In other words, every pair of hinges or pair and a half of hinges for a particular door is identified on the box as this is a set of hinges for this particular door. And pack each item complete with necessary parts and fasteners as manufacturer's original packing. All of this information is important. And everything that comes to the job site needs to be signed for. So if you can't find it, you have somebody that signed for it. Hopefully they'll be able to find it for you. And that's why it's important that this material is ordered and delivered in a fashion that it doesn't come to the site before it's needed. So it just sits around for weeks or months, and it shows up on the job site when it's ready to be installed. It's not late. It's not holding other people up. So this ability to get things on the site at the right time is very important in the scheduling aspects of it. But everything has its own specification. Let's pop out of this one and just look one more item. Let's find, let's see, lavatories. So this is going to fall under freestanding baths with feet. Oh, there's a bathtub. Why would that show up under lavatories? I thought lavatories were sinks. Let's type in sinks. All right. Floor sinks, washroom systems. This one's got specs. This is actually for toilet partitions. It looks like washroom systems. I got a video. InPro, the obsessive protectors of building and people. Ooh. All right, well, there you go. So here's Impro's uh, specifications for their corner guards, protective wall coverings, cubicle curtains, interior signage, expansion joint cover assemblies, and solid surfaces. And it gives you the spec section here that it falls under. So 06, solid surfaces would be a finish type material. 61, if we just look at the view of that specification, it includes shower and tub surrounds, stainless steel grab bars, window sills, anything that's going to be covered to protect it. So those things are all included. I've seen, if you look at some of our older buildings on campus, I've seen specification books that were maybe an inch thick for buildings that were built back in the early 1900s. Today, we are talking spec manuals that are several volumes of information, either electronically or on paper, and the drawing files are 70 to 100 sheets as opposed to a dozen sheets when it had to be done by hand. So the easier it is to get this information, the more litigation we have out there, the more we have to cover ourselves with these specifications and drawings that are very specific and particular to the type of work we're doing. So with that, I'll close it out, but just giving you a sample of what goes into the construction documents. I know it's not the most interesting thing in the world, but I think it kind of brings everything together. When I start telling you to name a drawing a C100, that indicates it's a civil drawing, and the spec sections that we fall under. As you get further and further into this in your education here at the university, you'll run into these things more as far as putting together documents that need to go out to the public for bid, or are just there to protect you in a building construction project to make sure everything works. So with that, I know chapter 19 was only a few pages, but it covers a lot of information that I think is the basis for everything that we do in our drawings and specification world. So I will leave it at that.